Give everybody a few minutes here. The webinar just went live, so people are just joining in now. So welcome. All right. Thank you all for joining us this morning. My name is Brett Stanton. I'm the Executive Director of the Asphalt Pavement Association of Michigan. And I want to welcome you to today's webinar, the features and favorites of today's asphalt paver. We've got some great presenters here to talk with us about the features and favorites of asphalt pavers. First off, I just wanted to start by thanking today's sponsors, AIS Equipment, as well as Michigan CAT, for so generously sponsoring this event, making this possible. Also want to thank our audience here for joining us here today. This webinar will be recorded, so if there's somebody else within your organization that you think would benefit from this, or you want to watch it again yourself, feel free to let us know, and we can give you a link to this recorded webinar so you can watch it at your desire. So first off, I think probably most everybody is a Zoom expert by now, but in case you haven't done these webinars, just wanted to point out a few of the controls. The chat function, which may be disabled for this one, but anyhow, you can chat with me if you have anything as the host. You can also raise your hand if you're having issues, and I will reach out to you and try to make sure we get those rectified. Sometimes in the Zoom world, if you're having issues with audio or video, sometimes it's easy just to disconnect and then jump back on. That usually solves a lot of the issues. The Q&A portion, that's probably the most critical thing here on this slide, is either located at the bottom of your screen or at the top of the screen, depending on what version you have. We will utilize that for today's Q&A. We'll hold the Q&A to the end, but if you have any questions throughout the presentation or any of the presenters' presentations, feel free to jot those down as you think of them, and then we will field them all at the end. Should we run out of time, we will make sure that we respond to those all in typewritten format and get those out to you. So as advertised, we will offer PDHs, professional development hours, for the time you spent today here. We'll be offering a total of an hour for this webinar. In order to get full credit, you'll have to be here for 85% of the session. We will email those out at the end of the session or shortly thereafter once we get the final Zoom report on who attended. So next, without further ado, I want to get into the goals for today's webinar. So reaching out to both the presenters, we had a conversation about what a good webinar would be on asphalt pavers. This was a brainchild of our Education, Training, and Events Committee, having some more equipment-tailored webinars, training things on such. So we reached out and talked with Nars and Todd and discussed what would be a good topic. And so we landed on, what are the things that asphalt paver owners have equipped on their equipment, but yet don't utilize or don't necessarily know it's on there, but if they knew it was there, would make their life a whole lot easier. So we tried to focus on the top 3 to 5 things that fell in that category. And then from the presenter's point of view, what are the things that are out there and you see time and time again, people either not adhering to or violating best management practices, and then talk about those things. And then of course, we wanted to talk about some of the new technologies that are available out there. So these are the goals. Hopefully we hit those. And then without anything else, I will get on with the show. So our first presenter is Todd Mansell. He's with Caterpillar. He's a civil engineer who has worked in the asphalt paving industry for over 30 years as a laboratory and field technician, lab manager, field inspector, materials engineer, designer, and quality control manager for employers in both the United States and Canada. Todd delivers paving and compaction training and consulting for Caterpillar customers worldwide. Todd is driven by passion for quality paving and for trying new and innovative paving equipment, technologies, and paving practices. Todd is an active member in several national and international paving industry associations, committees, and task groups. His personal interests include fishing, woodworking, and history. So without further ado, I will welcome Todd Mansell. So thank you, Todd, for presenting here. And you probably can't steal from me, can you?
Yeah, I think I got it there.
Perfectly. You've got the power. So, all right, without that, I'll let you take over. Thanks, Todd.
All right. Thank you, Brett, for the nice introduction. And yeah, I'm got a lot of stuff to cover here today, and some of it is what I would consider pretty basic, and I'm sure a lot of you know, but I will go through a lot of this fairly quickly, and then if we do have questions and stuff, like Brett said at the end, please feel more than free to type in your questions, and we'll take care of any of that at the end. One thing I would like to say too, just before I get started, thank you all again for attending. And a lot of what I'll cover, you're going to see yellow iron in these pictures because that's who I work for. But a lot of these features and things I'm talking about are on, all the different brands of pavers and stuff out there on the market. So with that, I thought I'd kick off. I mean, we talked about operator comfort was one of the things to talk about, and efficiencies, things like that. One of the things we see on most of our equipment nowadays is some form of what we call eco mode, just environmentally friendly, lower fuel consumption on the machines when that's engaged, or it may even just be an automatic thing. But I still see people running our equipment, even manually throttling it up and all that, and basically wasting fuel and being a lot noisier than it needs to be. The systems are designed now to run at maximum efficiency, if you will, and have the power. And I'm not a mechanical engineer, so I can't explain it to you in detail. But the bottom line is you don't really need to be running it at those high throttles, except maybe in very rare circumstances. So that's just one thing, just wanted to mention. You got the eco mode, auto engine speed control when you leave neutral, that propels to get the right power that you need. And of course, we got all the, I call them the bells and whistles, heated seats and power, air seats. So all operator comfort type stuff there. Same with the airflow. And again, you'll see this with most manufacturers now are putting more consideration into the airflow around the machine itself. So fans sucking that hot air and fumes from down around the screed operators and expelling it, out the top or somewhere away from the operators on the screed. Another thing here, feature-wise, so here we're looking at typically when you get ready to pave, you're putting all your feed system, left-right conveyors, left-right augers in auto mode so that they operate off of the feed, or the feed system will automatically feed mix back to the screed once you start paving. Again, just little things to make it simpler. It's one button push now instead of having to push all 4 buttons, unless you only need the auto feed on the right side, for example. A big one that I like is number 3 here is what we call the clean out or warm up mode. And in the past and on the older machines, if you wanted to clean out the paver, you had to put the brake on, kind of fake it like you're in pave mode, so you've still got the propel lever forward. And then I always felt a little nervous standing in front of the hopper when I knew the machine was in drive, even though the brake was on. So little better safety device now. It's in neutral, but this is again for clean out and warm up. So it just runs conveyors and augers at a slow speed to get the oil, get the chains heated up, or again to clean out. Another thing on the clean out end of it, here you can see a folding front apron here. So that's another nice feature. I would call it sort of, I guess to some extent, operator comfort, but it's more for really for the ground crew cleaning out. Just makes it a lot easier to clean out those areas for shoveling. So when at the end of the day, a lot less strain. Again, I would just say it's a little bit more of a ease of work / maybe even a bit of a safety thing if you're worried about somebody putting their back out on that. And languages, so we've got a lot of crews. I mean, you know, English isn't always our first language. So again, for the comfort and quality of the paving we're doing, you know, we've got options of different languages on the operator's console, the screed consoles, and all that to help out so that people understand the menus and everything that they're going into, and the operator controls better, you know, if English isn't their first language. So dual operator stations, nothing big there. Again, that's been around for a long time. What is kind of new in the latest generation of equipment, and a lot of this stuff has just become available now because we have CAN bus systems and the electronics on the machines. So CAN bus, computer area network, basically, you know, everything's controlled by computer somewhere along the line. So that enables us to do a lot of these, I'll call them features and comfort type things that we never had in the past. So in this example, you could have all your conveyor settings, all that. If you move to the other side on the operator station, all that's carried with you. Where, you know, in the old days, you'd have to go to the other side and then reset your conveyors and feed system and all that stuff. Personal preferences, I'm not going to go through all these. There's, again, because of computers and CAN bus systems on the equipment now, there's a bazillion things that we can go in and customize. So timers, that's kind of a nice one when you get to and we've had these in the past as well, but there's a lot more now than there used to be. But we've got timers, you know, for delay on the grade control system, the idle, throttle up, throttle down, screed vibration, you know, when that kicks in after I leave neutral, we can go spray down. So there's, again, a million things we can go in and I call it customize now to not only personal preference, but, you know, to gear it or fine tune it more to our operation. Canopies, more of a European thing, but, you know, you can get cabs and windshields on pavers. Again, it's just a comfort thing really for operators. Screed heat. So that's been around ever since pavers have been around, but electric screed heat in the last 20 some odd years has been fairly standard. But what we've done here is integrated the generators with the engines now, so they're not a standalone generator. What that's really done is two things: reduced a lot of fuel consumption for that electric power for the screed heat and other auxiliary power like your lights and all that. But it's also made the noise levels in and around the machine a lot lower. So a lot lower decibels when you're around that equipment. Service and maintenance wise, remote grease fittings, again, cooling systems that get that cold air out and away from the operators. So variable speed cooling fans, and again, stuff we didn't have years ago on some of the older machines. Quick change heating elements. So this is a big one from a service end. No need to remove the screed plates. These heating elements just slide out and slide the new ones back in without having to remove and replace screed plates and reset those. Service calibrations, diagnostics, again, because of computers on machines now, and we can do a lot more in terms of diagnosing or at least helping the the mechanics ahead of time. In a long story short, the machine will tell us a lot of what's going on or going wrong if something's going bad on us, or if we need to do a calibration, and we can let the mechanics maybe know ahead of time before they even get there. We've got codes and literally written codes, not just a number, but it might say screed heat element or something like that to help out on the service end. Screed heating, again, this is just show one screen, but showing different things, diagnostics and that type of thing. Big one here is what we call kind of predictive maintenance, if you will. So the screed heating elements, just used as an example. Basically, the system tells you ahead of time that, hey, these things got 20% life left in them. You probably want to replace them before it actually gets to that failure mode. So don't worry, all this electronics kind of scares me too on my new vehicle that I drive, but they still have what I call the limp home features. So you've still got mechanical toggle switches underneath the console that if, you know, electronics, propel, steering, any of that failed, you can still run the mix out and actually still pave with it. Wouldn't be real convenient, but you can get rid of that mix and still get the machine, get some trucks emptied, get the machine off the road if you had to. Telematics, so just kind of expanding on what I just talked about in terms of diagnostics and that sort of thing, all kinds of information on the machine. And then when we get to telematics, it's basically remote monitoring. So all of those codes and that type of thing that you can see as an operator or on the equipment are also available remotely to, you know, the dealership or the, you know, the owner of the machine itself. So you can log in, get alerts, all that type of stuff online, basically, in terms of product maintenance and then the alerts on fuel levels, error codes, all that type of stuff. And smooth tracks. So again, not a lot to really talk about here. Again, they've been around for a long time. I personally really like the smooth track pavers, good flotation, good traction, and all of that. High wear options for screed plates and floor plates on your paver. And again, that's available. All the manufacturers offer that, and there's even aftermarket versions available as well. One thing I do like here, and this is what we call a lockout feature. So on the screed operator's console, we get everything set up and we're paving along. Every once in a while, you know, you got your hand on there or you accidentally hit something. And the one I've seen, to be honest, hit the most is either like auger height or extender slope or crown. So you can lock those things out so that, and it doesn't mean you have to have a code or anything to get back in. What you do is just hit the lock button. So if I'm putting my hand on there, accidentally hit the crown or something, I'm not going to mess up my mat. You just tap the unlock button and then you can go in and use those features that you temporarily locked out. So it's just a handy kind of, I call it a bit of a safety type thing. So you don't screw up your mat by accident when you're paving along. On the paver setup, talk about a few things here. So one of the things, and I'll just go through different ones here, integrated automatic grade and slope systems. So very handy compared to having the left and right screed controls boxes that actually had the computers in them. Now with the integrated system, the computer is on the machine. No need to have a left side box and a right side and keep it with that paver and calibrated with that machine. So it just simplifies things a little bit. And of course, a more simplified user interface. One thing that's different too with the newer grade control system, so it's the operator up top on the tractor can operate it. It's a little clumsy for him to do it, and it's intentionally that way, but they can control it from the operator station, both sides. And of course, down on the bottom, you can control it from the left side or the right side. And you've got the split screen mode where you can monitor and control both sides on the grade and slope from one side. So that's, again, just to me, a handy feature. It's a good way you can get the guy on the left side fired if you're on the right side and you mess up his grade. But it's no, it is a handy feature. You know, somebody doesn't show up for work one day, or they need to go do something else, you can at least monitor the other side and, again, control it if you had to for a little bit. Another thing I like with the large displays now on the grade and slope systems is just the ability, and this guy is just going through a super elevation. He's got pie plates marked out, so he's changing slope manually, but he's using the automatic grade and slope system to look ahead and actually be able to see on the screen where he needs to be. So he's looking at pie plates, but he's got the big display now, which we never used to have. So he can, even if he's controlling it manually, can still view the actual value on the screen instead of dropping his level on the mat constantly, and get a smoother transition. So again, we could do this in the past. It's just easier and easier to do now. Sonic averaging ski, excuse me, sonic averaging ski, nothing new there, but most of us are using sonic averaging skis now on our machines. They're portable, easy to set up. Big thing here is inside the paving width, whereas when we get to a contact or a drag ski, we're going to be outside our paving width. I've seen jobs where we're running a drag ski on one side and a sonic ski on the other, so you can mix and match. Lots of ways of doing that. But again, there's nothing new. These have been around for years, but I just wanted to cover them on the grade and slope system. One nice thing from a diagnostics or a connectivity standpoint on the new machines is you're able to see everything that's connected. So on this screen that you're looking at right now, it's showing grade and slope displays up at the operator station, the left and right on the screed operator, showing the slope box is connected, showing a grade sensor on the right side, and then the one on red in the top left is telling you that it's not connected. So the machine saw that sensor, it's no longer seeing it. So maybe a cut cable, some shorted out, who knows, but for whatever reason, the machine's not seeing it now. So for those of us who remember swapping cables and all that, this makes life a lot faster and a lot easier than going through all that trial and error, trying to figure out if a sensor's bad or a connector or a harness. There's a busy screen showing a lot of things, but when we get into automatic grade and slope, it's also calibrations. So again, I'm not going to get into the details on this, but basically the valve toe point cylinder calibrations for automatic grade and slope, it's a fairly automated process now. So we park the paver on a level ground, null it out, go into the menu to calibrate that toe point cylinder with the grade and slope system. And we only do this once a season. Maybe I'll do it once every time I get on a quote high profile job. Only takes about 10 minutes aside, not even once you get set up and on a level ground and nulled out. But it's all automated. So you just hit go and it's going to walk you through the menu to calibrate the toe point cylinder with the grade and slope system. Normally, we're only doing this if we change out a toe point cylinder, a solenoid, anything wiring to do with the toe point control or the grade and slope system. But again, I'm doing it on a big job before I get started because it doesn't take long and it just makes me feel better that my grade and slope system's calibrated to work properly with the toe point cylinders. 3D paving, I know Nars is going to talk about this, so I'm going to skip over it. Just one slide here to show that it is a thing that we're using these days in paving. One thing I wanted to show here, multiple screed features. So these are things we didn't have in the past. So screed raise and lower, that's pretty obvious. Counterbalance or screed assist, float on the screed. So several buttons here. The ones in green are the ones that we're using typically every day when we're paving. The other ones are, I'll call optional or not always used. Screed lower lock, for example, on this keyboard is for a tamper screed, or you've got downward pressure. Counterbalance puts uplift pressure on those screed cylinders, basically makes the screed a little bit lighter, if you will. But counterbalance is not something we want to typically use. Maybe in a fine sandy mix where that screed settle, or that mix isn't supporting the full weight of that screed. But counterbalance, typically not something we want to use. If we're getting a screed settlement mark, when the paver stops between trucks and that breakdown roller takes it out on the first bypass, don't even worry about using counterbalance. Because every time we use counterbalance or screed hold or screed lock, which is a newer feature on there. So counterbalance is on constantly, or 100% of the time when you're paving. Screed lock or screed hold only engages when you come to neutral. So you could use it to minimize the amount of any screed marking or screed settlement when the paver stops, but it's still not a cure-all for a screed settlement mark. You might not have the mark there, but you're also going to have a bit of variation in your compaction because that screed was locked or held in position until you left neutral and took off again. And of course, paver stops regardless. You've got different temperature zones there where the paver stopped will also affect compaction. Just going to slam through a few of these things. Modulating speed of extenders, so that's nice because when we get to smoothness, how fast you wing in and out if we're doing variable width. Ideally, we try to stay to constant width when we're on a smoothness job, but if we are winging in and out every time I bump those extenders, it affects my IRI. So we can modulate the extender speed to go faster or slower depending on the type of paving we're doing. And I think my picture's missing here, but we've also got on the manual overrides. So in the past, manual overrides were on or off, and that's still true. If you run the manual override, it's going to go bring that mix and conveyors back at full blast. But now we can set the manual overrides so that when I do hit it, it's not running those augers at 160 RPM. It's still going to run them fast, but again, we've got different ranges now that we can select, so it's not as aggressive. It's not actually throwing rocks and affecting our ride quality when we use those manual overrides. It's got friction steer. That's basically locks the steering of the paver in a certain percent of turn, or when we're going through radiuses and things like that. So that's a nice option now to hold a constant radius, or even doing an off ramp or something that's a constant radius, we can lock that. Speed sensors, I was on a job a week and a half ago, and they didn't have their sonic feed sensors for bringing the mix back. Well, and these guys were running their manual feeds constantly all day until they got a new feed sensor. Well, now again, on the new machines, you can just set the feed sensors to 0, manually set your conveyor and auger speed, and then you don't have to constantly run those manual overrides and again, affect your smoothness. Lots of different, I call them anti-segregation kits and setups, and it just depends on the manufacturer and what issue you might be having. So if you've got centerline striping or different things like that, there's all kinds of different setups you can get. So here you see a bar across, preventing a lot of mix from going back under the chains. You've got reversing augers, deflector plates, all that stuff. You've got radar between the material transfer vehicles and the paver to keep that spacing. The big thing here, you could probably minimize paver stops or even transfer vehicle stops, even though we're using a transfer vehicle. Every time we have to stop the pavers, it affects our quality. Being able to set our paver speed in advance. So on the old machines, you had to speed dial up to your paving speed from 0. when you started out. Now you can preset it before you leave neutral on your initial takeoff, and that's even going to help your takeoff. Other things, we got wide width kits, and again, I'm not going to get into the details on this, but a lot of times I see people paving wide on jobs and when they should be set up with auger and tunnel extensions for the wide width paving, and kits are available. You're going to have bracing out there to hold those mainframe or tunnel extensions. We never want to have augers out there without tunnels in front of them. This is just kind of a top view showing, you know, how that brace holds the end of that auger segment when we get out on a wider width paving setup. And again, it's just all about quality, right? So we look down on the top and managing that head of material to half auger height all the way out to the end gate. And screed heat, I'm just gonna skip through this, but it's, again, just more user-friendly nowadays on the new machines because it shows our actual screed plate temperatures as they're heating up, and then they turn green once they're heated up and we're ready to go. So that's all that electric screed. You turn it on now and you just forget it. Generator, part of the engine, will just kick on and off automatically as needed when and if the screed plates need to be heated up during paving. Once we get going, it's pretty much the heat of the mix that's keeping those screed plates hot. And there's the screed assist I mentioned earlier, so we can go in, or the screed lock, either function, we can go in and set that uplift pressure, how much we're gonna put on those cylinders that raise and lower the screed to hold it in place to minimize settling of that screed, or to help us when we're paving that fine sandy mix that doesn't wanna support that screed very well. So configurable and all the pressures, and it always has been, but it's a lot easier now to do on a screen than going down underneath the deck. Hill hold is a nice feature if you're paving on grades, going especially uphill. Once that paver stops, or is pushing a truck and stops, or truck takes off, the paver wants to do what? Go back a little bit, and the screed might leave a screed mark in the mat, leave a bump that we can't get out. Well, hill hold feature just holds the brake on for 2 seconds after you leave neutral when you start back up, and it stops that paver from rolling back a little bit. Again, just preventing a screed mark in the mat that might affect our smoothness. Front wheel assist, if we're on the wheel pavers, you've got front wheel assist, which is two wheels, or you've got all wheel drive, which is all 4 front bogies. And again, it's really just for traction, or if we're doing a lot of uphill paving, and you can adjust the torque on those bogies as you're paving to the point where they're not going to slip, so you're going to get the maximum amount of push going uphill. And low entry hopper, so again, this is just optional whether you get a conventional hopper height or what we call a low entry hopper, depending on the trucks that you're using. And augers and mainframe tunnels have been raise and lower together. You get the auto raise and lower, you can turn on or off, or I should say enable or disable. So when you pick the screed up, you're not forgetting to pick the augers up, and then you hit something with those augers when you're moving the paver and end up breaking them. I think NARS is going to talk about the screed itself, so I'm not going to get into that. Big thing here. What I would like to just say is we've talked a lot about the screed here, or I'll talk a little bit. NARS will talk about the screed, but all the electronics, all the bells and whistles, all the stuff we're talking about have not changed since the screed, free-floating screed, was first commercialized. So we've got all these electronics, all these ways of monitoring things. We still have to do our, quote, best practices, proper setup, and all that. All these other features can help us. They're great tools, but they're not going to fix poor paving practices or poor paver setup. A few things quick on the screed. So we've got, again, I'm not going to get into details on screed. This is just showing a vibratory screed. There's a lot of different options for screed widths nowadays. But again, vibration. It's got extra XW, which is basically extra wide. So the last one you could go to maximum on this one, 24.5 feet. Get the extra wide setup. You can go out to 33 feet or 10 meters. And then you can also get the tamper screed versions of those with the tamper bar in them. So they've got speed settings on the tamper. They're more of a European type screed with the tamper screeds. And a few things, end gates, hydraulic end gates are nice. A lot of crews like them. They're obviously fast reacting, or can be fast to raise and lower, as opposed to cranking. You don't have to get out in traffic to raise and lower those end gates. And with the heated end gates, they're nice. I like the heat in the end gate just to avoid or keep those springs clean so that they're always free, so I can keep that end gate down and get a nice longitudinal joint. And even foldable end gates where they fold in behind to help out with transport width. A few things quick on material data management. NARS is going to cover this, so I'm just going to blow through these slides. But this is one version where you've got the e-routes, where you've got the desktop version and the mobile app version. So I'm just, again, going to kind of skip through this. I believe NARS is going to cover the material data management. What is I'll just say in short, what's really nice about it is it gives you so many ways of managing the job, the trucking in real time. And to me, that's really the power of these material data management systems, and finding out where loads are, when the next truck's going to be there, all that good stuff. And then there's lots of stuff you can drill down with later in the office to look at to try and, you know, improve, fine tune your operation, figure out where the weak spots are, and become more efficient in terms of quality and cost, right? E-tickets is part of it. So again, not going to get into details here. You can pull up individual tickets. You can find where a load went within a certain level of accuracy. All the driver trucking information's there. Create reports, send it off electronically by email. Dashboard, and for the office setup where you can look there and see all your jobs going at once and get a quick visual of, you know, tons put down versus planned versus actual, and again, just tons and tons of data in there. Paver mounted thermal, and I'll close out with this. So this is paver mounted thermal profiling. So here we're just looking at a thermal camera on a paver, and specifications, you know, height, accuracy, all that good stuff can be adjusted to different paving widths or mat widths. So it's an infrared camera monitoring the surface temperature of the mat as we're paving. Again, to me, the power in this is real-time information on the machine while we're paving. I'm not going to go through all the words here because I just got a couple slides I wanted to show you on a few examples of what I've seen or used. Everything here, and again, this will be available after, you know, for anybody who wants to go through all these bullet points. But what I want to point out is a couple examples. So with the thermal profiling, I can look at my paving operation if I'm using end dumps, windrow elevator, transfer vehicle, see what's doing well for me. Because what does uniformity of temperature affect? Uniformity of compaction, right? And our smoothness. So looking at different patterns, this is one from MnDOT, but this was just showing paver stops, end dumping. You can look at the thermal. The low-hanging fruit on this for me is actually just even looking at the number of paver stops and how many minutes I was stopped. This is auger height. So again, I'm just saying with this thermal data, you can look at it while you're on the screed and you can make a tweak in your auger height. You might see a difference in your surface temp on your mat. And conveyor speed, if I look at a pattern and I start seeing streaks in my mat, thermal, I can look back and determine, you know, hey, my feed system, my feed sensors are named right. Like my augers are coming on and off, or my conveyor speeds are too fast and too slow. So there's a lot of things I can quickly pick up, just even operation of the paver and the screed, by looking at that thermal data in real time while I'm on the paver. So I know I blew through a lot of things there, and I apologize for, I guess, for being fast. But with that, I will finish up here and turn it back to Brett.
All right, thank you, Todd. Share my screen here real quick. As I said in the chat box, if you have questions, please feel free to type those into the Q&A, and we'll answer those at the end. So next, our next presenter is Nars. Nars joined the asphalt industry in 1990 as a project engineer with Ingersoll Rand's Paver division, where he led the development of asphalt pavers. He has also held positions with other paving companies as paving applications engineer, product support manager, and product manager. Nars is currently employed with Work in America as application and technology specialist. His responsibilities include developing product specifications and providing support for paving applications and intelligent construction technologies. The one thing, Nars, I'll turn it over to you. And I want to make sure, the one thing I want to get out of this is how to appropriately pronounce Vugala.
You did good. Vogla.
All right. Thank you. It's all yours, Nars.
All right, I'll take it from here. All right, can everybody see me?
Yes, sir.
Welcome to APAM favorites, features and favorites of today's asphalt pavers. Brett did a pretty good job there introducing me, but I think he lied on a couple of things. So some of the topics we'll try to cover today, Todd did a pretty good job in overlapping with me. We try to avoid duplication. So I'll focus a bit on the principles of the free floating screed, what is forcing us to do what we're doing today. We'll look at the evolution of screeds, what are the different types of screeds, where we came from and where we're heading. And then we'll look at innovations in paving features that help you do a better job out there, makes your job easier, make it more comfortable, give you better quality, better smoothness. What are some of the features that allow you to accomplish that? And then we'll get into intelligent construction technologies. Where is our industry going? What's the feds doing? What are different states doing in terms of intelligent construction? So I always like to get back to basics. These are the things that force us to do what we do today. The 5 forces that holds the screed to grade. We all know there is no mechanical or hydraulic lock that holds the free floating screed to grade. It's held to grade by 5 forces. So consistency is one of the most important things relative to a consistent mat, consistent density and smoothness. So weight of the screed is always constant. The head of material, we always have good controls to allow you to balance the head of material. It's the pull force and the reaction and frictional force that are forcing us to use more technology today to help us manage these forces. Why are some of these things forcing us to do what we do today is temperature, like Todd says earlier. Temperature consistency is critical for consistency or consistent performance of the screed and rolling. What's happening when the screed is compacting the material? If you look in front of the screed, they all have a strike off. The strike off shares off that amount of material, allowing it to flow under the screed. Due to the angle of attack and the radius or the bullnose of the screed plates, we get our compaction from that point to that point. What's happening in that process is the larger stones are sliding against the fines, using the asphalt as a lubricant to gain compaction or to give you your final compaction at the trailing edge of the screed plate. And then, of course, the roller comes along to give you your final compaction. So the asphalt acting as a lubricant, if temperature changes, the viscosity of the asphalt changes, and so the ability of the aggregate does not move as easily if the material gets colder. So temperature could be used to monitor the performance of the screed and the final product. And that's what's driving the use of thermal camera, which we'll get into later. If I can play this video and if it will work. I don't know if you guys could see it. As you can see,
we're not seeing that, Nars.
you can't see it?
No.
All right.
Maybe you should unshare and then share that all applications.
Right now.
There it is. Yep.
So you can see the larger stones are sliding and rolling a whole lot easier because the viscosity is not there to hold it together. If we get into another mix design with more higher viscosity, then those larger aggregates will not roll as much. So that is just looking into what's going on in terms of all right, I will have to find a way to I'll get back in there. All right, I hope you guys can see me again.
Yep, we can see you.
Okay. So what's happening there is this, if the temperature changes, the viscosity changes, and the ability of the aggregate to move becomes more difficult to get screed compaction and the final compaction from the roller. So we'll get back into that discussion when we talk about intelligent construction technologies. Now let's look at the different types of screeds out there. Today, we have two of the most popular types of screeds are rear mount screeds and front mount screeds. Rear mount screeds, the extension is towards the back of the end gates. One of the big challenges with these types of screed is when you're doing commercial type work and you're constantly extending and retracting, it's difficult to manage this material to allow you to retract if you're running out to catch a driveway or around a mailbox or an island or anything like that. And you also have a much longer end gate, so your handwork tends to increase more significant when you're doing commercial type work. These are referred to as front mount screeds, but equal with front mount screeds, where the front to back dimension of the extension is the same as the front to back dimension of the main screed. But you have a much shorter end gate. So from that standpoint, your handwork is minimized. However, you have material management to deal with in the middle here, as opposed to rear mount screed, where it's out here, you can see it, you can manage it, you can shovel it out. In this case, you can't. So this type of screed have evolved into what we refer to as unequal with front mount screeds. Unequal with front mount screeds have a much narrow extension, so there's no need for a strike off in the middle. And if you notice, the inside is tapered. So as you extend and retract, that material pushes forward and does not get trapped. This seems to be the most popular screed today. In the past, there was always a perception that these types of screeds are not real screeds. Well, if you notice, when I talked about the 5 forces that holds the screed to grade, its weight of the screed is one of the 5 forces, and not weight front mount or weight rear mount. It's weight. As long as the screeds are rigid enough, the performance of the screed in terms of smoothness and density is no different whether it's front mount or rear mount. The advantage is versatility. These are referred to as compaction and high compaction screeds. Compaction screeds have a tamper bar, which is a moving device, sits in front of the screed that moves up and down to give you your compaction. High compaction screed have the tamper bar and also multiple pressure bars at the back. With these type of screeds, you can achieve up to 100% density. Now, I will not mess around with that video again and lose some more time, but with a high compaction screed, you could pull 2 lifts at the same time. One paver with a high compaction screed in the front, doing your binder 3-4 inches. A second paver roughly 4 feet behind the first paver, laying your surface mix. The paver in the front have a transfer conveyor sitting on top of it, transfers your surface mix over to the paver at the back. That type of technology is being used in Europe today. To eliminate joints, you can have 2 paving train in echelon, pulling bridge deck to bridge deck, eliminating all joints, 2 lift at the same time, thinner surface lift because it's integral paving, no tack in between the 2 lifts, 1 traffic control for 8 lanes, So it's a significant amount of advantage, and that is what we need to dream for our market here in North America. So rigidity is what's important, whether it's front mount or rear mount screed. If you have rigid guide tubes, no sloppy bushings, whether it's a rear mount screed or a front mount screed, the performance will be the same as long as the weight is there and all the adjustments are correct. So whether it's a rear mount screed, you can pave up to 28 feet wide, pulling 2 lanes. Whether it's a front mount screed, you could pull 28 feet wide again, doing 2 lanes. This is a project through Columbus, Ohio, pulling 2 lanes at the same time with a front mount screed. Same with a front mount screed, pulling a 7-foot shoulder together with a 12-foot main line. So if you have the rigidity and you have the weight, you can pull 2 lanes, you can pull a shoulder in the lane, you can eliminate a joint, which we all know is the first place to have failures. If you do a bad job and you have to fix it, then we have the fixer-upper paver. High quality, narrow width paver that could pave minimum 20 inches wide, so you can mill off the failed joint and you can put it back on with a high quality screed, 20 inches wide. The same paver could also go up to 7.25 feet wide, or with some bolt-on extensions, you could get up to 10.5 feet. The same paver could be used for different type of applications, utility patching, narrow width patching, shoulders for lane shift during construction, sidewalk, jogging trails, golf cart paths. So all of it become available with a narrow width, high quality pavement. So those are some of the slides to describe what we do with screeds today in our industry, from front mount to rear mount, compaction, high compaction screeds. Now we'll look at paver controls, fast and current. In the past, we had toggle switches, hydraulic joysticks, a few toggle switches in the screed. That was about 30 years ago. Today, we have what we refer to as intelligent machine controls. Intelligent machine controls more than likely are canvas control. And with that, it allows us to perform intelligent construction that the feds are pushing, that we refer to as intelligent construction technologies. Whether it's a tractor control or it's screed control, it's all intelligent machine control. So with the canvas control, we can improve operator comfort, we can improve paving quality, we can improve troubleshooting. We all know when a paver goes down, we have 10 trucks in front of it. It's very important to get the paver back up and running to save those loads. And of course, that will allow us to involve in intelligent construction technology on your screed control and on your tractor control. We also give you a remote control. You can hold it in your hands and you can walk along the paver and perform all your paving functions. Get off the heat, get off the vibration. No need for you to stand there. I'll come back to this control a bit later to show all the different functions we have on it. But here you can see we have duplicate, auger, and conveyor. We have our toe point up and down. And if you're an automatic grade and slope control, this allows you to increase or decrease your mat depth. We have screed extensions, hydraulic tunnel, berm. If you're in berm country, Michigan is berm country. We have slope, we have match height, and we have lockout for all those functions. So if you accidentally hit the switch, it sees the function. It mounted, it's magnetic back. You could mount it anywhere there is steel, but there's a bracket on the end gate. So you can walk along the paver, you can grab it, move along the paver, and you can perform all your paving functions. What are some of the other technology we have that makes your life easy? Cummins Tier 4 technology, 250 horse, no DPF, but it has a DEF and an SCR, but no DPF, so which means no need to bother about regen for a DPF. You also have an economy mode, 235 horsepower at 1700 RPM, reduce noise, reduce wear and tear, but enough horsepower to get all your functions, all the paving functions. We also have a hydraulic driven fan controlled by the coolant temperature, air temperature, that allows you to, again, reduce noise, reduce wear and tear, and reduce fuel consumption. We also have a clutch that's between the pump drive gearbox. It's not the best picture, but there's a clutch that disengages the engine from all the pumps if functions are not being used. So rather than sit there and churning fuel, burning fuel, and wear and tear in your pumps, if you're just sitting there idling, the pump drive gearbox disengaged from the engine. So again, reduce noise, reduce fuel consumption. Some ease of operation features, trim steer. Todd talked earlier about the brake on the steering wheel. Similar feature, ensure smooth radius in turns. Why do we want that? If we're zigzagging through the turn, then our screeds is moving side to side. We break those 5 forces in equilibrium, we end up in a rough ride. So it's always important to hold a nice smooth turn into a nice smooth radius into a super elevated turn. Same control, display your head of material. So as you run low in your tunnel, you see your bar chart gets empty. That means you're low and stop paving. One of the things we will talk about earlier is your material delivery management system to ensure consistency of material feed. And again, to keep those 5 forces in equilibrium. Also display the toe point position to avoid twisting in your screed when you're sending at the joint. So your toe point is being displayed up here. Also on your screed control, you have the same display so the operators can see exactly where his toe points are at to avoid twisting. Screed hold and screed freeze. Whenever the operator pulls the F&R lever to neutral, the screed goes into a hydraulic lock so you don't have any settling. As the operator takes off, the screed stays locked for about 4 seconds or 18 inches, so it does not give you a hump. When we stop, like we said earlier, the temperature, the mix gets cooler, the viscosity gets stiffer, and your R force increases. So with the screed freeze, it holds the screed to grade and prevents it from climbing as it goes through that colder head of material and does not give you a hump. Those are all automatically done as the F&R lever is brought back to neutral, and as it stroke forward to go again, 4 seconds or 18 inches, and that feature kicks out and allow the screed to go back into flow. Track plow, make it easy on you. You don't have to step in front of the tracks with a shovel when you have piles in there. You just drop it in the afternoon, in the morning, pick it back up in the afternoon so you don't run over curbs and tear it up. But it's a simple tool that allows you to achieve smoother ride with less work. So those are some features on the paver that helps you perform a better job and improve on quality, improve on smoothness. Now we'll look at some innovation in paving equipment and process. A material management system we'll talk about a bit later. For ease of operation, you have your automatic, manual, and on-off for your auger and conveyor in 3 different locations. You can see it here on your tractor control, on your screed control, and on your remote control. We also allow you to set your material height. I hope you can see it. It's hidden at the back here on the auger sensor. So you can set your material height at that position, and you can also set your material height on the screed control. Whenever you hit those plus or minus sign, the screen that shows your percentage automatically pops up so you don't have to flip through screens to find it. We also have the smart wheel that allows you to slowly run your extension in and out if you're trying to match a joint so you don't disturb those 5 forces in equilibrium again. Or if you're going out to catch a driveway, you hold it down, it doubles your speed, and it also boosts your augers because it knows you're going out, you need more material, so it kick your augers up an additional 40% if it's not already at max. So those are some of the features that help you with material management. Again, ease of operation on the operator side, hydraulic tunnel, so you don't have to go in there and clean that front up with a shovel constantly. You just touch the center switch and it pops that front apron up about 60 degrees and dump that material back into the flight chain. You could individually run each hopper, or if you hold that switch down constantly, then the front will come up and then your 2 hoppers will come up. Makes life easier for you during the day. Another feature that helps you reduce your effort at the end of the day is an automatic greasing system that greases the feeder bearings, just the feeder bearings. Some diagnostic system we put on the paver. Why? Because we know paver will go down. It's built by human being, but if it does go down, we give you easy access to all the valves. Open the side door, 1 on each side. Each valve has an LED light that if you have a complete electrical circuit, the LED light comes on. We all know 8 out of 10 times when a paver goes down, more than likely it's an electrical problem. So we give you a diagnostic system built into the machine, no internet service required, no laptop required, no license required. It's all there. You just need to learn to use it. So most paver have, like your car, you turn your ignition key on and a bunch of sensors will tell you whether the functions is good. Your second level of diagnostics is for certain problems, it tell you what it is. If the problem is fixed, it give you an X. That's a nice feature when you have intermittent problems, so you can constantly see when that problem occurs. And again, when it's fixed, it will be X'd out. If there's no X on it, that problem still exists. That's your second level of diagnostics. Your third level of diagnostics, if you remember the control panel, you can go to a switch, hit the switch. If the circuit is complete from the switch to the input pin of the controller, the circle will go dark. Let's say that your extension is not working. Here's my extension switch. If I hit the switch, the circle will turn dark if the circuit is good from the switch to the input pin of the controller. If not, we could go into the inputs and the outputs and look for all the inputs and outputs. Now, an operator may not know that or should not know that, but the mechanics usually do. So the mechanics could call the operator and say, hey, look at that screen, tell me what you see. And he could quickly figure out what his problem is before he leaves with his service truck for the job. So these are all built-in diagnostic system on the paver that helps you speed up your troubleshooting and keep that temperature in the truck to the right level that we can still consume that asphalt. So backup controls also for your feeder systems. So if we have a feeder sensor failed or a cut cable, we lose our automatic mode, we can go into that same diagnostic tool. We can turn the automatic mode off. When we do that, that number now becomes a percentage of max RPM of the augers. Likewise for the conveyor, it becomes a percentage of max RPM for the conveyors. So we could continue to pave in an automatic mode and not have to constantly run those switches in a manual mode and have your head of material fluctuate, which cause rough ride or prevents you from achieving your best smoothness number. Integrated machine, integrated grade and slope control built into the machine today. All of that comes with intelligent machine control. The same control can allow you to interface with TopCon, Lycor, Trimble, and Pave 3-dimension, which I'll get back to and talk about later. But your integrated machine control, you have a split screen. Your operator on the left can see what your operator on the right is doing, or vice versa. The left guy could control the right, or the right could control the left. If you don't like that, you can turn it off so that the left control left, the right control right. Again, you have your desired grade and your actual grade. So when your actual grade starts to deviate from your desired grade, the machine will make a change to bring the actual back to your desired. You can also set your slope. So rather than going down constantly with a smart level, you can monitor your slope on discrete control. Everything built in. You have enough storage on the pavers to keep your cables and your sensors. Your brackets usually stay on the end gate. It takes 2 minutes. Grab your cable, grab your sensor, hook it up, hit calibrate, and in less than 30 seconds, you could be paving in automatic mode. One of the reasons why many operators don't like to use automatic grade and slope in the past is because it's too much work to bring a suitcase on board, on site, hook up all the cables and the junction boxes and the controllers, calibrate it for the different settings, whether it's valve offset or deadband. None of that is required with the integrated system because it's designed and built for that particular paver. So you don't have to set valve offset or deadband or any of those types of presetting. Even today, sensors have an additional light. You have your standard up and down arrow that shows you when the machine is making a change. But today we take it to another level. We put some lights in there that shows you when the sensor is in range. So you start mounting your sensor in a low position. You slowly start to bring it up until you see 2 lights light up either on the backside or the side. That tells you you're within operating range. You lock your bracket in position. You hit set on your controller, turn it on, and you're pretty much ready to go to work. These sensors also have an LED light built into it. If you get caught paving in the dark, then you have a nice bright flashlight, as you can see it down here, that can help you through the dark hours without having to bring a generator on board. There's your LED light. Okay, so those are some of the features that we have today to help you make your life easier. Now let's look at intelligent construction technologies. Like I said earlier, intelligent construction technologies is being driven by or become reality because of intelligent machine control. These are some things that are pushing by the feds and several different states. Really 3D milling and paving, paver mounted thermal profiler, which we'll talk about today, but also including intelligent construction technology, intelligent compaction, IRI smoothness, ground penetrating radar to check density, and of recent material delivery management system. So in the next couple of slides, I'll cover 3D milling and paving, paver mounted thermal profiler, and material delivery management. These are some of the states that are involved in this today. You can see their names out there. Each one of these states required data from these systems to be analyzed slightly different. We are equipment managers. We are not in the business to write analysis software for every state. So fortunately for us, these states have financed a software called VEDA. So data from all these systems goes uploaded into VEDA. So contractors and state agencies and DOT inspectors will log into VEDA, grab the data, and run the analysis based on their needs. So the equipment guy role is to provide data into VEDA. As you will see when we get into the material delivery management system, it will be the same software that the data from all these systems are uploaded into. How would this benefit our industry in the future? That's what I will try to accomplish here in the next couple of slides. First, let's look at 3D paving and milling. So we can pave one dimension, which is in the past, we control the depth left or depth right. That is one dimension. Some folks refer to as two dimension because we're controlling left and right, but it is one dimension, it's the depth of the pavement. We can also control the width, and we can steer the paver. So that's called your full 3D paving. So what are some of the things that require today to pave 3D? Of course, it's three unique knowledge base. Too many contractors wants to go into 3D paving, grab a paving crew that never heard of the word 3D before, and expect these guys to learn how to pave 3D overnight. This is a very challenging tool, and it needs knowledge, three different knowledge base. So what are the three things that is required to pave in 3D? We need machine controls. In our case, and also in as Todd mentioned earlier, it's built into the machine control. So the first thing we need is machine control to control the toe points. The next thing we need is positioning instruments. We are not in the business of making positioning instruments. The expertise there lies in TopCon, Trimble, Leica, maybe a few other guys. And then we need a job file, which could be a 3D model. So the 3D model is what's used with the 3D positioning instruments to tell the machine control where it's at, what the grade, what the width, and what's the direction of the pavement. So these are three unique knowledge base that is required. We need to know how to build a file. We need to know how to use these 3D positioning instruments, whether it's millimeter GPS or it's UTS. And then, of course, we need those to tell the machine control what to do. There's two types of job files. We could have a new project, totally designed on 3D. One of the things that's being pushed today by FHWA is BIM, Building Infrastructure Modeling, that mandates the use of all new projects designed in 3D and built in 3D. So for new projects, we have a 3D model. For existing surface, TopCon and Trimble makes a system. I know TopCon is called Smooth Ride. You can mount the device in a pickup truck and you can scan a base, build a 3D model, plug that 3D model back into the paver or a mill, and let the equipment follow the 3D model. Well, we're not here to talk about mill today, but we could talk about pavers. So once we have the model, we feed the model back, in this case, into a TopCon control box using TopCon GPS receivers to tell the paver where it's at. Now, the 3D model coming from the TopCon controller will tell our sensors what the grade needs to be at that particular latitude and longitude. So now our sensors take that information, drive it back to the machine control to control the toe point to achieve that depth that is being driven by the 3D model. That is TopCon technology. That is not Vogler technology. For more information on that, reach out to your local TopCon dealer. But that will make it easy. In the past, we would either mill it or we would do a leveling course. If the foundation is good, we could use this system and we can lay some more asphalt where there is a low spot to compensate for roll down and give you a smoother final product without having to do a leveling course, or in some cases without having to mill it. You can take the same system and use it on the mill if you have to mill it. So that's the second way of building a 3D model, whether you use it on a paver or you use it on a mill. Let's look now at material delivery management system. It's AASHTO MDMS e-ticketing. It's an expansion of the e-ticketing system. This is currently being worked on. Myself and Todd are involved in some of the review committees on this system. So we know a little bit more about it today. These are 5 different areas where information will be flowing, of course, into Veda. If you look at the fleet data, is dump equipment identification number, a geofence on the plant, a geofence on the job site that shows where the truck is at, and also GPS in the truck that you can monitor the truck from the plant through its route to the job site. Also the date and time where the truck dumped, the latitude and longitude to where the truck dumped. So we can monitor that truck from the plant all the way to the job site. Shows exactly where it dumped. Now, if we use a material transfer, the dump location may not be exactly where the machine is, where the asphalt is laid, but in this specification, I think it's a 200-foot accuracy is expected relative to dump location. Then we have, of course, the data that will be entered by the agency, which means your DOT inspector on the job site, a whole bunch of stuff. We're not going to cover the details there. These are stuff that the contractor have to enter. You notice 2 important pieces of information. There is material temperature and air temperature. Now, we already have a weather station mounted on the paver that gives you that information without having to manually enter it. So these are all information that the contractor has to enter. And then, of course, the source, which is a plant, which was where the whole e-ticketing system started originally, but now expanded into the material delivery management system. Now, why is it called material delivery management? As I said earlier, we want to ensure consistency in temperature. We want to achieve that. We have to ensure consistency in the material delivered to the paver so that the paver does not have to stop. Again, that will ensure consistency in the pull force, which is one of the 5 forces that holds its weight to grade. So material delivery management system ensures consistency of the material supplied to the paver, ensure that the material that was meant for that particular job is dumped at that job location, and also capture all this information in an electronic file that could be shared among systems. So it's a digital format system designed to capture delivery data. Now, here's a slide from a source from NRRA. It's not my slide. I just happened to borrow it from NRRA, but you could see all the different systems that we talked about. A couple to pick on is 3D milling and paving, dumping information into the material delivery management system. In this case, will be Veda grabbing all that data. Paver mounted thermal profiler sending information up there. Intelligent compaction sending information into Veda. Material delivery management system sending data into Veda. Now, this data is in a sharing format. So we have all this data. What else can we use it for? So here is your material delivery management system. Data is being stored in the cloud. Veda database used for analysis of their data, but Veda is also used for analysis of the intelligent construction technologies. So the material delivery management data would be flowing from paving equipment to the cloud database or MDMS database, plant into the cloud, hauling equipment, e-ticketing. The agency will be sending information into it. Contractor will be sending information into it. But we also have the intelligent construction technology sending information into the Veda database. So now we have all this data. Say, for instance, the paving equipment guy can go back into the database, pull information from the truck, and could be able to provide to you more real-time as-built information, because now we have all the data. What else can we use the data for? I'll show you some of that in the next couple of slides. But first, looking at the paver mounted thermal profiler, thermal camera mounted on the paver, looking 6 feet behind the screed. We have a weather station mounted on the side that gives you all your weather information. We have a temperature sensor mounted in front of the paver that gives you your ground temperature. So the thermal profile display in front of the paver operator, so he can monitor that profile and he can raise a red flag if he sees anything that's suspicious. So this is a data collecting tool. We do some analysis and give you a thermal profile, but there's much more analysis that is required by every state, some of which are a little bit different. The thermal camera, or in our case called a road scan, could have mounted on any Vogla -3 models, where again, the operator gets to see the display right in front of it. Camera is easily mounted because it's plug and play. All the connectors are already part of the electrical systems. Speed sensors are part of our Orga Plus operating system. So all you have to do, it takes 2 minutes to plug the camera in and turn it on, and you're ready to go to work. Tractor operator can start and stop the camera right here, gives them the display up there. So that is collecting data. Now we have the data, what will we do with the data? So like I said earlier, Veda will be analyzing the data for different states. But we have a system called WITAS Paving, where WITAS Paving does its own analysis and give the contractor some more information to improve his process. So the foreman enters the details, and we have direct download from WITAS to Veda, so inspectors and everybody else can use the Veda analysis. So here, an operator could go to, or foreman or supervisor, go to WITAS Paving, which is on Vogla server, or Workin server. Select a date. Now the project could be several days, so you select a start date and you select an end date. That will be done over here. You enter your project name. You enter an email address for anyone seeking this information, where it's a state engineer, an inspector, a foreman, your supervisor, whoever the case may be. You enter their email address there. Any notes for that particular job. And you can start the project on the paver, or you can start the project on a smartphone or a tablet. The paver creates a Wi-Fi using a TCU within a 250-foot radius. So the paver talks to this smartphone or a tablet that's within 250 foot of the paver. That information gets sent by the TCU to the Workin server. At the end of the day, when you hit end, the project finish, you hit end, whoever name is on the email instantly gets a report that shows you certain information. So once you hit end, you get 3 pieces of information. This one shows you your paver performance, which I'll get into details shortly. This one shows you your thermal profile, which will be the WITAS thermal profile analysis. The same information exported to Veda will give you the Veda analysis as required by different states. And of course, your trucking information. So your paving information will really show you, the blue shade is paver active, which means the paver is paving. The red shows you sitting in pave mode, which means you're waiting on trucks. The light blue or the orange shows you whether you're moving into position in pave mode or you're traveling to the job. So at the end of the day, you can look at your paving process in terms of paving time and idle time. You can get the same information with your truck information. So without duplicating the effort, we'll skip that. At the end of the day, you get that report, but during the paving process, if you have the thermal camera mounted on the paver, you could put a smartphone or a tablet in the roller cab or with the roller operator, and he can see the thermal, he can instantly see the thermal profile that the tractor operator sees. And then he can roll accordingly. With the MDS database now, we can grab the truckload information because that's data sharing. we can grab the truckload information to our server. We could put a screed width sensor on the paver that tells you exactly how wide you're paving. We know our width. We also know our depth. That's plugged in now, but in the future, we could put sensors in there and know precisely how deep we're paving. We can shoot you a thermal profile with your exact position of your screed because of the screed width sensor. So you see the exact profile, and you can trim off X amount with some states require that. And we can display in front of the operator how many trucks he's got sitting in front of him, how many tons is paved, how many tons is left to be paved, how many feet is paved, how many is left to be paved, and we can give him more real-time yield. The foreman sitting in his pickup truck, somebody sitting in the office could see all this information real-time. That's as-built information. So at the end of the day, we make your life easier. You don't need to collect any tickets anymore, especially with COVID. We eliminate the tickets. You don't need to roll and get your length of paving. That's all built into the paver distance control. So we know exactly how wide how fast you're paving. Sorry, what distance is paved. We also know the exact screed width because of the screed width sensors. We could display that information in front of the tractor operator for the foreman. At the end of the day, we give you a report that helps you analyze your process and improve for the next day or the next project. And of course, we can help the roller guy do a better job because now he knows where his cold spots and the hot spots are. And with that, I will turn it back to Brett. Brett, you could take control and we can go to questions.
All right, thank you, Nars. We have one question that came in came in earlier, and Todd answered it a bit. Todd, do you have any? The question was, what is the ideal paver's speed? Todd, you provided a little bit of information. Do you have anything more to elaborate on?
Yeah, I mean, the only thing I'd add to that question, I mean, it depends on the production of the job and obviously meeting your quality goals from compaction and that. But the only thing I'd say there is if you're using automatic grade control, maximum paving speed is about 60 feet a minute. And if you get faster than that, you can still pave all right. But if you're running automatic grade and slope, the delay of, signal to the toe point cylinders and the machine control and all that starts to lag just a little bit, and you lose a bit of preciseness. So there you go.
Right.
I guess that's, yeah.
Thank you, Todd. So another question, both of you provided a lot of great information today. If you had only the opportunity to provide one take home for the audience, what would that take home be? So go ahead, Todd, and then we'll let Nars.
My one take home would be to figure out ways to implement this technology, use it in real time in the field, because that's where this is the most powerful. We can look at it in the office after, and and don't get me wrong, it's still valuable, but try to figure out how to use this temperature data or whatever it is in the field real time and make our quality better that way. Thank you.
Well, from my standpoint, if you're serious about the paving business and you see your company being involved in paving in the future, I'll strongly advise to get someone with a civil engineering degree, surveying background, and understand 3 dimension, understand latitude, longitude, because that's where our future will be. All those 5 intelligent construction technologies I talked about is paving process documented on the same latitude and longitude using GPS. And down the road, you can go back and pull those data up 3, 4, 5 years and see exactly what to do. So contractors will have to gear up with that knowledge base to be able to use those systems.
All right, thanks, Nars. I think there's a comment that came in about better design for gate width. So I said as a question I had for you, Nars, you mentioned the report at the end of the day that go through paving width. Is that we to the point now where that's accurate enough where DOTs would take that information and consider it to be accurate? Sorry, it cut out on you.
Yes, that will be accurate to the millimeter.
Okay.
Very precise.
All right. How about you, Todd, on the cat paver, the Weiler screed?
On the paving width, that we don't have that automated right now. Yeah, that's coming in the future with the position sensing screed extender widths. Yep.
Okay. Another question that came in, textured screed plates, fad or future?
Todd, I'll take that only because I went out there and experienced some of it.
Yeah, me too.
We've been technology in the past. Can a metal have made something similar? The advantages to texture screed plate compared to a screed that is designed right, I'm not sure if the additional cost could balance.
I think the jury's still out from the ones I've seen that are textured. We don't make one, but I know there's aftermarket ones that are, I won't name brand names, I guess, but they paved a road right by my house. I mean, you can still see the texture, but I can't feel any smoothness issues or anything. And so I'd like to see some core data and density data on.
Thanks. So I guess one final question here in the interest of time, and we'll think about the future. And so what major advancements, I know you guys talked about a lot of technology coming forth with, machine control and stuff like that. Is there anything in addition to that? What are we looking for in the future here? What does the asphalt paver of the future look like?
I think I'll go first if you don't mind there, Nars. I think, all the stuff we've talked about today, it's not all what I would say 100% there in the sense that, yeah, it's out there, but it needs fine tuning to be really good. And not to take anything away from any of that, but it's, so that I think the paver setup itself and being as we get more things on position sensing cylinders, all that, all I do is go up to the paver, type in, I'm paving 12 feet wide. I want 2-inch compacted mat when I'm done. And here's, how many tons I want to put down today. And it's going to set up the paver automatically, adjust my extender heights and set my angle of attack and all that stuff, as opposed to having the crew doing it on the ground manually to get just better takeoffs, consistent takeoffs and all that. So that's my thought. Not necessarily that of Caterpillar.
So from our standpoint, we've had this technology for over 7-8 years now in Europe. And I personally have requested our company not bring that technology here into North America market. Mainly because it's difficult for our contractors to find crews to use that technology. And the technology we have today, you go out on a job site and you train a paving crew and they learn it and they use it. But we know our industry, 6 months later, the operator quit or the crew quit, and then some new guys jump on the machine. Nobody's there to train them. So that technology sits there and don't get used. So this is an industry problem. And I think our industry needs to face that head on and manage it better. So technology, from a paving standpoint, the manufacturers are holding it back.
Okay, just a couple quick ones. One on CAT E-routes. Todd, is that something like somebody wants to access that? Is that a service they need to get turned on, or how does somebody go about implementing that?
Yeah, so it's got the positioning and all that. So basically, the hardware part, you go through a Caterpillar dealer to get the hardware you need, and then yes, it is a subscription-based thing. So you're going to pay so much per month I believe, per machine. I don't get into all that part of it, but that's basically how it works. Yeah.
All right. So the short of that is if you don't see it around right now, you got to call the dealer and they'll give you more information. Okay.
Yeah.
And then,
but it is available. Yeah.
Okay. And then on the cat paver, the crown lockout button, does that lock one side or both sides?
Yeah, you can set it up to lock one side or both. So whatever your preference. If you trust the guy on the left side, then you can leave his unlocked.
All right. Well, thank you very much. I want to thank our sponsors one last time. Again, Michigan Cat and AAS Equipment. You can reach out to either one of those depending on the paver manufacturer that you're looking to get in contact with about e-routes or other questions. Like I said, we'll make this webinar available. If you want a copy, please reach out to us. Work on getting it out there so you can access it. Also want to thank both Todd and Nars for spending the time to prep their presentations as well as give the presentations today. Thank you very much for your time, and it was very good presentations. I enjoyed. I'm assuming I speak for the audience as well. The content was good. Sounds like a lot of exciting, cool things are out there, and a lot of stuff is headed our way. So, and then finally, I want to say thank you to the audience for your time and participation in the questions. And then finally, leave you with our next webinar, which is next week, next Wednesday, and it is on asphalt plants as the drum turns, how to maintain and optimize your drum's performance. That'll be at the same time, 11 a.m. Eastern time. And if you want to register, you can go out to our website and go through the process there to register. So thank you again, Nars. Thank you again, Todd, for your time. And we hope you enjoy your week, and happy Easter, everyone. Thanks for participating.
Thanks to the audience.
Thank you, everyone.